Good morning. Today is Monday, December 12th. I'm doing a video lesson today. Hi, guys. And we are looking at day 4 today. So get day 4 out and have it out in front of you. I'm away today at the board office, but you can also find the link right here on day 4 in our OneNote file. And we are going to look at that today. Just looking ahead at this week. So today we're going to look at day 4. Tomorrow coding will begin and you'll get your Unit 4 test back. Wednesday we'll do some more coding. Thursday will be a review and Friday will be the test. So it's a very short unit, but there was lots that we've been talking about so far. Well, so far, what have we been talking about? We've been talking about types of graphs, interpreting types of graphs. We've been talking about box and whisker plots. And we've also been talking about just making different graphs. I think we just focused really on box and whisker plots for making graphs on Excel. And then today we are looking at curves of best fit. So on your test, you'll have different types of graphing, the box and whisker plots, and then today's lesson, and then some coding stuff. All right, so let's get right into it. Again, at any time, you are more than welcome to press pause, rewind, fast forward through this video in order to get this lesson completed. All right, so lines and curves of best fit. Let's press pause and make sure everybody has day 4 in front of them. All right, so when points on a scatter plot seem to follow a pattern, we sometimes draw a line or we can have a curve of best fit to model a relationship. This allows us to make predictions, either it be like in the present or in the future or in the past. So a line of best fit is a straight line that passes through as near to as many points as possible on the scatter plot. Okay, so let's fill in some of these things here. So there's a good line of best fit should follow the trend in the data. Oops. You're going to follow the trend in the data, and it doesn't always have to start from the origin. It doesn't always have to start from 0, 0. Sometimes it does, but it doesn't always. Right, because you can have a line that's partial or you can have a line that's direct. All right, so we want to follow the trend. That just means like if it looks like it's positive, your line should also be positive. It should not be going down negative. And we're going to draw some good lines of best fit and some bad lines of best fit too. All right, so another thing that we want our line of best fit to do is to go through as many points as possible. And then we also want to have the same number of points above and below this line. Okay, so let's go ahead and draw a good line of best fit. So we have some data right here. So part 1, we want to follow the trend. So it doesn't always start, as we can see, like that's not going to be a good line of best fit, right? We want it through as many points as possible with the same number of points above and below if we need points above and below. And again, it doesn't always go through the origin. So something like this, let's count and see how many points are above. So 1, 2, there's like 3 above and 3 below. That looks like a great line of best fit. One thing, it goes through the trend. It has the same number of points above and below, and we're also going through it as many points as we can, right? But if you can't go through as many points as you can, that's okay. You can have the same number of points above and below. Right? What we don't want this line to look like this. It is not a constellation, all right? So we're not connecting the dots here. We also don't want our line to look like this. Like Hey, Miss Johnston, we have the same number of points above and below, like almost, but this is not following the trend in the data. So make sure it's going in the way of the data, it's positive. What are we thinking here? Gabe, is this strong or weak? All right, awesome. Do you concur, Jasmine? Yeah, definitely looks strong. All right, so this would be definitely a strong positive correlation. All right, so we can see here again, it's a line, and now we're going to go and look at and see some of these graphs below here. So which of the graphs below have a pattern? Explain. Okay, so let's go again, see if we can state if it's positive, strong, and then today we're also going to add in one more word. We're going to say if it's linear or nonlinear. So there should be 3 words we talk about when we talk about um, our scatter plots. Okay, so here we can see what kind of pattern is happening. Well, is it a kind of like a curve happening? No, it's more of a straight line. So we want to do a really nice line of best fit, almost the same number of points above and below. It's going in the way of the trend in the data. That looks good. All right, so here we're going to have, this looks kind of, would you say strong or weak? Yeah, it kind of looks weak. How can you tell it's weak? Like what's the difference between like this graph and this graph? Yeah, what are you thinking, Evanel? Yeah, the dots are a lot more scattered here, so it's definitely going to be weak. They're not as close together, so they're not strong. So if they're more spread apart, they're weak. And here we have it is still positive and it is linear. For this one, again, you can kind of see like the trend in the data is still going upwards, right? It's not so much a curve that's happening. It's still kind of going upwards. But again, this will be all the same as the last one. It's still pretty weak. It's still positive, and it's still linear. And then here for this one, again, they're not all like in one kind of like place all together. They're a little bit scattered here. So again, weak. Um, and then it looks like it's kind of going downhill here. So weak, negative. And again, it looks linear. It has to have like a very distinctive curve, kind of like the one below, to be nonlinear. All right, why is a line of best fit not a good model for data in each graph here? So why would a line of best fit not be a good indication of the data here? Well, hopefully you guessed that this is, what is it, Addison? No correlation. So then we're not going to get, we're not going to know is it positive, is it negative, is it weak, is it strong? And then same with this. This is non-linear. This is kind of showing like a strong though, like because all the points are really close together. In grade 10, you will talk about how this is a negative curve that's happening here, but right now we're just going to leave it as nonlinear. Okay, so interpolation. What we want to do here is we want to examine data. So interpolation, I want you to think of examining data inside the graph. All right, so, and this is usually what we have been given. So information that we have been given, we can talk about like what does the graph tell us, and that's called interpolation. Extrapolation, or like exit, would be examining but also assuming data outside the graph. So it's kind of like an approximate. Again, please pause at any time in order to write these definitions down. All right, so let's get a couple of measurements here just to talk about what these two words mean. Well, let's say we were going to measure people's heights, right? And versus like your age, year or age, and your height. Well, when you're a little baby, it'd be like down here, right? You're really young and you're not so tall. And then you're getting older, maybe grow a little bit. And we're taking a whole bunch of people's data from the class, and that would be good. So you guys are around like 14 years old, right? All right, so we would draw like a line of best fit, let's say, and then from there, let's go say we want to define Gabby's height, and at 14, so we would go and look at where Gabby's height is, and she's 14 years old, and if like this was all her data here, then we would say, oh, 14 years old, this is how tall Gabby should be. All right. But when you get older, let's say, Gabby, you are now 50 years old. Does that mean that you are going to be really, really, really super tall? No, you're not going to be super, super tall. You're probably actually going to, like most people do, like shrink when we get older in age. So what we're looking at here is when we're looking at inside the data, this is what we call interpolation, or to interpolate of what the data is giving us. So if we recorded all your heights and everything like that up to you're 14 years old, that would be interpolation. So we would get your data right from the graph. However, when you turn 50, the line of best fit is used to extend and see if we can get another piece of data outside. This would be extrapolation. To extrapolate something, to assume something that continues on. However, in this case, it doesn't make sense, right? And when you extrapolate, obviously, we're not going to have people who are like 8, 9 feet tall when they turn 50 years old. So extrapolation, you kind of have to kind of take it as with a grain of salt, right? So that just means that you really have to kind of like figure out what is your data telling you, and then does this make sense? Okay, but anyways, that's interpolate, that's extrapolate. You can look at it in terms of like house prices, right? Like before COVID and then after COVID, if we were to extrapolate, yes, that would be like a good estimate of how the prices of houses have increased over time. All right, okay, let's keep it going. So here we want to extend the line. We extend the line of best fit in order to extrapolate. All right, that's it for this video. Please go and click on the next video link.